Welcome to section 5.5.1, absolute value transformation. So we're going to talk about the parent function absolute value of x and the transformation, but first we're going to talk about in terms of graphing. So here I wrote out the parent function where it's labeled as f of x equals to the absolute value of x. So we're going to be using this function, and then we're going to talk about the relationship and how it looked like in terms of transformation for the graph. Now, when you're given with this function and you're trying to identify the vertex, so the parent function, the vertex, is always going to be at 0, 0. So let me write vertex at 0, 0, also known as the origin point. Now you can rewrite the parent function f of x equals absolute value of x with the vertex like this. This is x and this is y. So you can rewrite it as f of x equal to the absolute value of x. You could write either minus or plus 0. I use minus 0. Then outside the absolute value or behind the absolute value, I'll write plus 0. So if you look closely, here's the 0 for the x and here's the 0 for the y. And the reason I wrote it this way is because we're going to have two more examples where we're going to have numbers, and that's going to help us determine our vertex when it comes to graphing. Alright, what we're going to do next is we're going to work on making our XY table. So let me make my XY table. We're going to need this in order to graph. Now, since I'm making the XY table, I'm not requiring you to make it all the time for graphing. Is that as long as you understand the relationship with these points and how it comes in terms with the transformation, once you understand it, then you will be able to graph by hand or in your mind without using the XY table. Now, once you identify the vertex, which is at 0, 0, I'm just simply going to put it right in the middle. Now, why do we have to put it in the middle? It's so that once you're in the middle, you can determine your x values, which we need to plug in to make our y values, therefore make our coordinate points. So if 0 is in the middle, then what I'm going to do is pick the next two lower x values, which is -1 and -2. Then below, I'm going to pick the next two higher x value, which is 1 and 2. So I just finished picking my x value. Next, I'm just going to start plugging in, simplifying, and then determining my y value. So let's do the first one. X equal to -2. So what I'm going to do is I'm going to plug into this x. So f of 2 equal to the absolute value of -2. So the absolute value just simply makes the number inside become positive. And let me state it again. The absolute value makes the number inside become positive. It does not mean that the answer is always positive, because you gotta be extra careful if in the event you're gonna have a negative that's outside the absolute value, which we will cover in a future section. But let me restate it. The absolute value makes the inside number become positive. So once that happens, I'll put parenthesis +2, close parenthesis. Now the reason I'm putting parenthesis is in the event I have a number or a negative sign that's outside, if I do, then the moment you have parentheses, then you can distribute. In this case, we don't have anything outside, so I can drop the parentheses and I just write the number that's inside, so +2. And I'm going to put it over here. Alright, let me do the next one. X equal to -1. So that means we're plugging in -1 into x. So here, little error on my notation, this should have been -2. Saying that stating that I'm plugging in -2 into x. Same thing here. I'm going to plug in -1 into x. So this x here. So the absolute value of -1. So the absolute value makes the inside number become positive. So parenthesis +1. I don't have anything to distribute, so I will drop the parenthesis and write the number. So +1. Alright, now I'm going to do the next x value, which is x equals to +1. So I'm going to plug in +1 into x. So the absolute value of +1. So since the number is already positive, then I'm just going to write parenthesis +1. I have nothing to distribute from the outside, so I'm just write the number +1. Alright, lastly, I'm going to do x equals to 2. So plug in f of 2, or plug in 2 for x. So the absolute value of +2. So the number is already positive. So once I do the absolute value of +2, the number stays the same, and I'm going to include my parenthesis. Since I have nothing to distribute from the outside, I'm going to drop my parenthesis and write the number only. So +2. So here's my coordinate points. I have 5, including the vertex that was given from the beginning. So I'm going to use these points to plot my graph. So let's start off with our first point, -2 for x and +2 for y. So here's my x-axis, and then I'm going to zoom in a bit for y'all. Alright, so -2 for x and then +2 for y. Then -1 for x and +1 for y, which is right here. Then the vertex, which is in the middle, 0, 0. Now, the next point is 1 for x and 1 for y, which is located right here. And then the next point, 2 for x and 2 for y, 2 for x and 2 for y. And then let me get my ruler. So, this is my vertex, this is the middle. So I'm going to graph starting from the middle. So if I'm going towards the left side, I'm going to line up my ruler along these 3 points and make it straight like this. Then continuing from the vertex and graphing on the right side, I'm going to graph through these points, these 3 points here. So here is a graph of the parent function, the absolute value of x. So this is what it looks like. Now, again, I stated that we don't have to do the xy table all the time. What I do recommend is that once we start from the parent function, you memorize these 3 points. Because it's always best that we start from the parent function, and once we work on transform function, it's easy to move from there. So as long as we have a starting point, then we continue and then find our endpoint. Now we have the next function, g of x equals the absolute value of x minus 2 and then plus 1. So when it comes to graphing, it's always best that we find our vertex as our middle point. So in order to find our vertex, we just basically look at these 2 numbers here that I underlined. So using this function, the vertex will be at parenthesis +2, comma, +1, close parenthesis. Now, how did I find the vertex? Well, let me talk about the rules for finding the vertex. It always ties into the number that's with the x inside the absolute value, and then the number that's behind it. That's always the case when you're trying to find the vertex. Now the rule that I always follow, which I'm going to explain. So in order to find the x coordinate of the vertex, I'll follow the rule of opposite x. If you look closely from the function, you see how it's -2 or -2. So the opposite of -2 is +2. Now for the rule for the y coordinate, it's going to be same y. So if you look from the function, it's plus 1 or positive 1. If you look at the vertex, it's also positive 1. So regardless of what function you have, as long as you follow these two rules, to find your vertex is always opposite x and same y. So let's review. Inside is x minus 2. So if you look at the number, minus 2 is the same as negative 2. So the opposite of negative 2 is positive 2. So that's the x coordinate of the vertex. Now the number that's behind, since it's plus 1, meaning positive 1, so the y coordinate is same y. So the y coordinate is positive 1 for the vertex. So my vertex is 2, 1. Now once I identify my vertex, then I can set up my xy table. Alright, so I mentioned earlier that you should memorize the 3 points from the given previous example. So let me write those out. 0, 0, negative 1, positive 1, and positive 1, positive 1. Now we're doing the new one with this function. So let me write it over here. So this is our vertex, so that's our middle point. So let me write 2, 1 in the middle. Alright, so in order to determine our x value, since 2 is in the middle, you go one number lower, which is 1, and then you go with one number higher, which is 3. So let's do the work for these two. Alright, so the first one is x equals to 1. So I'm going to plug in to 1 into the x, so g of positive 1 equal to the absolute value of 1 minus 2, and then plus 1. So first I'm going to simplify the inside. So I'm still going to have the absolute value. 1 minus 2 is negative 1. Close absolute value, and then the plus 1. And then the absolute value will make the number inside become positive. So parenthesis, positive 1, close parenthesis, and then plus 1. I don't have anything to distribute from the outside, so I will drop the parenthesis and write the positive 1, and then bring down the plus 1. So 1 plus 1 is 2. So let me write 2 here. Alright, so the next x value, is 3. So I'm going to do x equals to 3. So g of 3, meaning I'm plugging in 3 into x, absolute value of 3 minus 2, close absolute value, and then plus 1. So I'm going to solve the inside. So I still have the absolute value. 3 minus 1 is positive 1, close absolute value, and then plus 1. Since it's positive 1, stays the same, so parenthesis, positive 1, and then plus 1. Since I don't have anything to distribute from the outside, I'm going to drop the parenthesis, so it's 1 plus 1. And then that will equal to 2. So I completed my points. Now before I graph, now the reason I wrote the table for the parent function and then the table for this function, if we look closely, you'll see about the relationship with the points. So let's take a look at the x values. From this point, it went from negative 1 to positive 1. So that is a difference of 2, meaning that it increased by 2 units. Due to the second point, if I compare them, same thing, from 0 to 2, it increased by 2 units. Then to the next point, same thing here. It went from 1 to 3, so it increased by 2 units. So there is a pattern, especially with the number 2. Now let's look at the y value. So comparing these 2 points, these two y value, it went from 1 to 2, so it increased by 1. Let's go to the next one. From 0 to 1, it increased by 1 again. So let's look at the next one. It went from 1 to 2, so it also increased by 1. So if we look at the relationship, all the y values increase by 1. That's typically the same number as we have here, plus 1. While the x value increased by 2, it doesn't seem to be matching up with minus 2. But once you see the graph, you'll see how it changed. And then let me zoom in a bit. Alright, so let's start off with the point. We had 1, 2, so 1, 2, which is right here. Our vertex, it was 2, 1, so 2 for x and then 1 for y. And then last point, 3, 2, so 3 for x and then 2 for y, so right here. So this is my middle point, the vertex. So I'm going to start graphing from there. Let me get my ruler. Alright, so I'm going to start from the vertex to the left side. So here it is, and I'm going to make it straight. As you can see how I made my graph straight, going through all the corners. Then going from the vertex to the right side. So here's the graph for the absolute value of x minus 2 plus 1. Now let's compare to the parent function graph. So here's the parent function on the left, and then here's the transform function on the right. If you look with the center of the xy table, so here's the center on the left, and then here's the center on the right. If you look at the vertex, you can see that from the parent function to the transform, that it went right 2 units and then up 1 unit. So that was the change or the transformation between the two vertex. But if we compare the points, so let's look at this left point of the vertex and this left point. So if you look at the coordinates, you can see that it went right 2 units and then up 1. And then I can say the same thing on the right corner point of the vertex. It went right 2 units and then up 1. So let's talk about the transformation. So what was the transformation when the function of f of x equals to the absolute value of x with the vertex at 0, 0 when it was changed to g of x absolute value of x minus 2 plus 1 with the vertex at 2, positive 1. So let's take a look. When I compare the graphs, if it was minus 2 inside the absolute value lines, then that means that it will translate right 2 units. So if it's minus 2 inside the absolute value line, then it will translate right 2 units. You could also write or say move right 2 units. So that's the minus 2 inside the absolute value. Now let's talk about the number that's outside. So the plus 1 that's behind the absolute value, when we compare the graph and the y values of the coordinate points, we saw that it translates up 1 unit. You could also say move up 1 unit. So if it was minus 2 inside the absolute value line, then it will move right or translate right 2 units. If it was plus 1 behind the absolute value, then it would translate up 1 unit or move up 1 unit. So make sure you have that in your notes and make sure you memorize the rules and the process. Alright, the next function we have h of x equals the absolute value of x plus 3 minus 4. So if I were to ask you to find the vertex, so remember the rule for vertex. So the first one is the x-coordinate. So plus 3, meaning positive. So the opposite of positive 3 is negative 3, comma, and then the rule is same y. Since it's minus 4, meaning negative 4, I'm going to use the same number, so negative 4. So here's my vertex. Opposite x, same y. Now, first I'm going to write the xy table from the parent function. So I'm just writing this for comparison, that's it. Zero, 0, negative 1, positive 1, and then positive 1, and positive 1 again. And then the xy table for the given function. So this is the vertex, so I'm going to start at negative 3, negative 4. So since negative 3 is in the middle, if I were to go one x value lower, then it'd be negative 4. If I were to go one higher from negative 3, it'd be negative 2. Alright, so let's start plugging in and finding the y value to make our coordinate points. So I'm going to start with negative 4. So x equal to, so that means I'm plugging in negative 4 into x. So it will be the absolute value of negative 4 plus 3, close absolute value, and then minus 4. So I'm going to solve the inside first. I'm going to simplify it. So negative 4 plus 3 will be negative 1. But don't forget, I still have the absolute value, and then minus 4. So the absolute value of negative 1 is positive 1, so parenthesis, positive 1, close parenthesis, and then minus 4. Since I don't have anything to distribute from the outside of the parenthesis, then I'm going to drop the parenthesis and then just write the positive 1 and then bring down the minus 4. 1 minus 4 will be negative 3. So let me put negative 3 over here. And then the next one, x equal to negative 2. So I'm going to plug in negative 2 for x. So h of negative 2 will equal to the absolute value of negative 2 plus 3, close absolute value, and then minus 4. So when I simplify the inside, negative 2 plus 3 will be positive 1 with the absolute value minus 4. So the absolute value of 1 is just 1, so parenthesis, positive 1, and then minus 4. Since I don't have anything to distribute from the outside, so it'll just be positive 1 and then minus 4. 1 minus 4 is negative 3. So let me write negative 3 here. Alright, now let's compare the coordinate points. If we look at the x values, so starting with negative 1 to negative 4, it decreased by 3 units. So similar to the number that we have here. So let's look at the next one. It went from 0 to negative 3. Again, decreased by 3 units. Let's check the next one. It went from 1 to negative 2. So again, it decreased by 3 units. So there's a pattern with the plus 3, or the vertex, negative 3. Let's compare it with the y values. So here's the parent function, and then here's the transform function. It went from 1 to negative 3, so it decreased by 4 units. Let's look at the next one. 0 to negative 4, so again, decreased by 4 units. Next one, 1 to negative 3, same thing, decreased by 4 units. So there's a pattern tying in with the minus 4 or the negative 4 from the y coordinate. So there is a pattern, there is a relationship. So let's talk about in terms of the graph. Alright, so I'm going to start graphing this. So the first point will be -4, 3. Sorry, -4 and -3. So -4 at the x and then -3 at the y. Then my vertex, -3, comma -4. So -3 and then -4 for the y. That's my vertex. And then -2 and -3. So -2 for the x and then -3 for the y. And then let me zoom in for a bit. Alright, so I'm a graph. So here's my vertex. If I were to graph to the left side, make sure it's aligned. So here's my left side. And then from the vertex to the right point, I want to align like so. There we go. As you can see, all my lines is going through each of the corners of the XY lines here. Alright, so if we were to compare the transform function with the parent function, which I have in my hand, in my left hand right here. So as you can see, the vertex of the parent function start at 0, 0. If we look at the vertex of the transform function, you can see that it went 3 units to the left and then down 4 units. And then you can compare each point. So the one point on the left of each vertex, you can see from the parent function to the transform, it went down 4 units and then left 3 units. Same thing, if I compare the right point of the vertex from the parent to the transform, it went down 4 units and then right 3 units. And it should match up or align with the coordinate points. So let's talk about the transformation. In terms of the equation, so if the parent function f of x equals to the absolute value of x with the vertex at 0, 0, and then our new function h of x equal to the absolute value of x plus 3, close absolute value, and then minus 4, with the vertex at -3, -4. So tie into the coordinate points that we examined earlier and the graph. So if it was plus 3 inside the absolute value lines, then that means that it translates left 3 units. You could also say move left 3 units. Now for the -4, when we were comparing the y values and the graph, if it was -4 behind the absolute value lines, then what happened to the y coordinates and the graph, it translate down 4 units. You can also say move down 4 units. So that's the relationship in terms of when you have numbers with the function. So plus 3 inside the absolute value, translate left or move left 3 units. If it was -4 behind the absolute value, then translate down 4 units or move down 4 units.